Today we will demonstrate about the magnet. Magnet are such materials, they attract each other even they are far away from each other. So it produce the magnetic field around itself when the other magnet or the other material come in that region, that other material will be attracted towards this material. Okay, even they do not uh, mm, touch directly each other. So magnet is such like material. So what is happening inside this material due to which it show such a property? So this material is made up of large number of the atoms. Each atom of this material have the electron. That electron is rotating around their axis. So due to their spinning motion, the magnetic field is produced in each atom. Each atom of this material is behave as a tiny magnet. So the magnetic field produced from the each atom of this material will support each other, and as a whole the as a whole, the one side of this material become the north and the other side of this material become the south. So if we bring this magnet towards the other material will be attracted towards this magnet. Okay, that will be attracted towards this magnet. So if we consider this material in the absence of magnetic field will not have any net magnetic field. Okay, because here if I bring this to this, it do not attract they do not attract each other. Okay, they do not attract each other. But if I bring the other if I bring the magnet here, okay, so this magnet attract now this body. Now this body is also attract the other. Okay, so in the absence of this external magnetic field, this material do not have the magnetic property. But now if we bring this magnet to this material, now this material become will have the magnetic property, mean that it will now attract the other just like the magnet. Okay, so what is happening inside this material? So in the absence of this external magnet, this material will do not have a magnetic property, because if I remove this, okay, then this material will not attract this material. Okay, so now I'm going to remove this magnet. So see here. Okay, so okay, I remove that. If I remove this magnet, then this material will lose their magnetic property. Okay, so uh, this material is called the magnetic material. Okay, this is actually the magnetic substance. In magnetic substance, this magnetic substance is also made up of large number of the atoms. Each atom consists of the electrons. That electron is rotating around their axis, and also circulate around the nucleus. So therefore, when the charges is in motion, it produces the magnetic field. So the magnetic field will produce from the each atom, and the each atom of this material will behave as a tiny magnet. Okay, so in the absence of external magnetic field, now this material, the magnetic field of the atomic magnet will cancel each other effect, and as a whole, this material is now do not act as a magnet, mean that it do not attract the other body. So here if I bring this toward this material, they will do not attract this material. Okay, they will do not attract this material. Now if I bring this material towards the external magnetic field, okay, now I bring this material towards the external magnetic field. The magnetic field of the each atom of this material will support each other. Okay, and due to which this material will also become a magnetic in the presence of external magnetic field. So therefore, we call this material as a magnetic material. Okay, so in the presence of external magnetic field, now this material also behave as a magnet, because here it attract the other material. If we bring the other material to this material, now this material is called the magnetic material. Okay, so those materials which behave as a magnet in the presence of external magnetic field. On the other hand, those materials whose magnetic fields, whose molecular magnet supports the external magnetic field, is called the magnetic substance. Now, on the other hand, we have this copper wire. This copper wire is non-magnetic. Okay, it is a non-magnetic, because if I bring this copper wire to this magnet, they will do not attract it towards uh, this magnet. Okay, so there is no attraction between these two substances. So this substance is called the non-magnetic substance. So inside this material, still the atoms are present. There are large number of the atoms in this material, but the molecular magnets of this materials will cancel the effect of each other. Okay, they do not support the external magnetic field. So therefore, this material is called the non-magnetic materials. Okay, so there are some substances just like this. Okay, this is called the ferromagnetic materials. Okay, this is called the ferromagnetic material, and such materials are mostly around the transformer. Okay, are they are used in the solenoid. Okay, so we have this circuit. Okay, in this circuit we have this this material. Inside this we have this green color material. So this is ferromagnetic material. Similarly, this is the green color present inside these wires is also the ferromagnetic material. Uh, Similarly, this material is also the ferromagnetic material which is present inside this coil. Okay, inside this coil, this material is called the ferromagnetic material. Okay, similarly, we have this other circuit. In this circuit, also the ferromagnetic materials are present, just like this. Okay, uh, this inside this body we have uh, the coil-like shape. Okay, inside that coil we have the material that is also a ferromagnetic material. Okay, here see there, there is also that that coil also consists of the centered material, which is ferromagnetic material. Now, what is the ferromagnetic material? What is the behavior of ferromagnetic material in the presence of external magnetic field? So this is that ferromagnetic material. This ferromagnetic material also be behave as a non-magnetic material in the absence of external magnetic field, because if I bring this substance, let's say this substance, to this ferromagnetic material, they will do not attract it towards this uh, ferromagnetic material. Okay, there is no attraction. But now if I provide the external magnet to this material, okay, now I have provided the external magnet to this ferromagnetic material. Now this is also behave as a permanent magnet in the presence of external magnetic field. Okay, in the presence of external magnetic field. So in the presence of this external magnetic field, this ferromagnetic material also behave as a permanent magnet because it now attract this material. Okay, so now this ferromagnetic material have some this ferromagnetic material have some property. Okay, so if we remove this external magnetic field, if we remove this external magnetic field, okay, I have removed it. So a small interval of time, this material have retain their magnetic property because again see here, if I remove this magnet, this material still will be attached to this ferromagnetic material for a small interval of time. Let's see here. I remove it. So for that small interval of time, that material still will be connect with this ferromagnetic material. So the ferromagnetic material have the ability to retain their magnetic property even if we remove the external force. So this material retain their magnetic property for a small interval of time. So due to this property of the ferromagnetic material, we use them in a transformer, in solenoid, in choke.
As we bring the magnet near to the nails, all these nails will attract it towards this magnet. So what is happening inside these materials due to which it has response to external magnetic field? There are some materials which do not affected by the external magnetic field, including the aluminum, copper, and gold. So, what is the physics behind the difference in the nature of these materials and these materials? We will discuss that here in this lecture in more detail. There are some materials which responds to external magnetic field. We call them as a magnetic materials. That include the iron, nickel, cobalt, and steel. On the other hand, those materials which do not respond to external magnetic field, including the aluminum, gold, silver, and copper. So here again, if we bring the magnet near to the nails, so what is happening inside these nails? So that has discussed here. If we bring the north pole of the bar magnet towards the nail, these nails consist of the large number of the molecules, and each molecule is behave as a thin magnet, and the magnetic field of each molecule will align in such a way that this side of the nail become the south, and there is the force of attraction between the north pole of the bar magnet and this south of this nail. So it has attracted towards this bar magnet. On the other hand, if we bring the south pole toward this nail, the thin magnets, the molecular magnets will the magnetic field of the molecular magnets will arrange in such a way that this side of the nail become the north, and it has also attracted towards the south pole of the permanent magnet. So if we consider a sample from the magnetic material and non-magnetic material, as I had discussed here, each material have the molecule, and the molecules itself behave as a thin magnet. We call them as a molecular magnet. So the molecular magnet and magnetic material is aligned in such a way that uh, it uh, it produce the net magnetic field. Okay, so we call them as a magnetic material. On the other hand, the non-magnetic material, the molecule still uh, produce the magnetic field. Okay, but they cancel the effect of each other. Okay, that the magnetic field of the each molecular magnet will arrange randomly. They cancel the effect of each other, and therefore it do not respond to external magnetic field. It means that it do not have a net magnetic effect As I have discussed that the nail consists of the large number of the atom, and each atom is behave as a tiny magnet, because here this is the atom have the electron. That electron is spinning around their axis. So when the charge is in motion, it produces the magnetic field around itself. So here this side of this spinning electron, the one side of this spinning electron become the south, and the other one is the north. Okay, and these poles will be flipped when the spinning of the electron become opposite. Okay, so when these electron is spinning around their axis, it produce the magnetic field, and similarly the magnetic field is also produced due to orbital motion of the electron. So this atom will have a net magnetic field. The one side of this magnet will behave as a south pole, and the other side of this magnet will behave as a north pole. So therefore each atom of the magnetized of the magnetic or unmagnetic material will behave as a tiny magnet. Okay, so let's consider the magnetic material. So let's say this is that magnetic material. Magnetic material have large number of the atoms. Okay, and each atom is behave as a tiny magnet. Okay, the origination of their magnetic behavior is as I have discussed here. Okay, so in the absence of external magnetic field, each each atom molecular magnets will be arranged randomly. Okay, so they cancel the effect of each other. Okay, so there will be no magnetic nature of that material in the absence of external magnetic field. So if we provide the external magnetic field to that material, okay, the molecular magnets of that materials will arrange in such a way that their magnetic field will support the magnetic field of external magnet. Okay, so therefore the that material will also behave as a magnetic material in the presence of external magnetic field. Okay, so here in this theory, the molecular magnet in a molecular substance mean that in magnetic substance each molecule is behave as a thin magnet, and the origination of the magnetic property of the each molecule as I have discussed here. Okay, in unmagnetized substances, that molecules of that tiny molecular magnets will cancel the effect of each other, and in if we provide the external magnetic field to that magnetic material, okay, the all tiny magnets will arrange in such a way that it support the external magnetic field. Okay, so if we provide the high if we provide the more intense external magnetic field, all all the molecular magnets will arrange fully towards the external magnetic field. Okay, so we call that as a magnetic saturation. Okay, so if we heat that magnetic substance, okay, so if we heat this magnetized substance, it will lose their magnetic property, mean that each molecular magnet, the kinetic energy of each molecular magnet will be increased. Okay, so that some of the magnetic some of the molecular magnet will cancel the effect of each other, and overall the magnetic property of the magnetic property of the magnetic material will be lost due to the external heat. Okay, so As I have discussed, the atom consists of the spinning electron, due to which it produces the magnetic field, and also the orbital motion of the electron is responsible for the magnetic field. But the spinning, the more preference will be given to the spinning of the free electron. Okay, the magnetic nature of the magnetic substances is mostly attributed by the spinning of the free electrons. Okay, so each molecule, material each material is a magnet. Okay, the molecule of each material, whether that is magnetic material or non-magnetic material, will be their molecule will have the net magnetic field. But in magnetic substances, they that all magnetic field support each other and responds to external magnetic field, while in unmagnetic materials, that molecular magnet do not support each other. Okay, so this was the theory behind the magnetism. Okay, now the magnetic materials are classified into ferromagnetic materials, diamagnetic materials, and ferromagnetic materials. So paramagnetic materials are those materials which are weakly attracted by the strong external magnetic field. So there are some materials to which if we provide the strong external magnetic field, that material will be weakly attracted towards their strong magnetic field, and we call that material as a paramagnetic material. Okay, so in paramagnetic materials, the orbital and the spin axis of the electrons in the atoms are oriented in such a way that they support they support the magnetic field of each other. Okay, so they support the external magnetic field. So if this is the paramagnetic material in the absence of external magnetic field. Okay, so their molecular magnet, okay, will cancel the effect of each other. So if we provide the external magnetic field, okay, these materials will align in such a way that it will support the external magnetic field. So here the the direction of external magnetic field is represented by this red color arrow, and the direction of the molecular magnet is represented by this blue color arrow. So here this blue color arrow support this red color arrow. Okay, so but here these material this this color, this blue color arrow do not fully support the external do not fully support the external magnetic field. So it has some uh, tilt. Okay, it has changed some of the direction. It is do not parallel with the external magnetic field, so therefore it is weakly attracted by the external magnetic field. Okay, the example of the paramagnetic field material including the aluminum and antimony. Okay, when we place that aluminum and antimony in the external magnetic field, it becomes weakly magnetized in the direction of applied field. Okay, now we have a diamagnetic material. In diamagnetic material, the orbital and spin axis of the electron in atoms are oriented in such a way that their field cancel the effect of the external magnetic field. Okay, so this red color is the external magnetic field, and here the molecular magnets will arrange in such a way that it will cancel the effect of external magnetic field. Okay, so therefore these materials are weakly repelled by the external magnetic field. Okay, so example of the diamagnetic materials include the copper, zinc, and bismuth. if we place these material in the external magnetic field, it become weakly magnetized in the direction opposite to external magnetic field, as we see here. Okay. Now, on the other hand, we have the ferromagnetic materials. These are those material which retains its magnetic property even if we remove the external magnetic field. Okay, so here this is these red color represent the external magnetic field, and if we remove this external magnetic field, the molecular magnet will still support each other in the absence of external magnetic field, and we call these such type of material as a ferromagnetic material. Okay, so in ferromagnetic material, individual atom behave like a thin magnet. Okay, so the interaction between these atomic magnets or the molecular magnet is so strong that they align parallel to each other. Okay, even in the absence of external magnetic field. Okay, so the magnetic domain of the ferromagnetic material is so small. Okay, but that magnetic domain consists of the large number of the atoms, about 10 power 12 to 10 power 16. Okay, as we have discussed in the previous lectures about the polycrystalline material. In polycrystalline material, we have the large number of the thin crystals. We call them as a grain. Okay, our domain. So each inside each domain, as we have discussed, the atoms are arranged in a regular pattern. Okay, so the atomic magnets will support each other in that particular arrangement. Okay, so therefore it will have some overall magnetic field. So the magnetic field of each domain will support each other in such a way that if we remove the external magnetic field, the material will still magnetize. We call that sort of material as a ferromagnetic material. Their domain is small, but it consists of large number of atoms. Okay, if we increase the external temperature to this material, these magnetic domain will be start vibration. Okay, so due to that vibration, uh, it will lose their magnetic property. Okay, so the each magnetic material will affect some of the effect of the neighbor molecular magnet, and due to which the overall magnetic property of the ferromagnetic material will be lows. Okay, so there is some temperature in which the ferromagnetic material will be converted into paramagnetic material. Okay, that temperature is called the Curie temperature. Okay, in ferromagnetic materials, all the atoms are arranged in proper way. There is a strong support or internal support to external magnetic field. Okay, if we increase the external temperature, that support is decreased. So the material will convert from the ferromagnetic nature towards the paramagnetic nature. So the temperature in which the material is converted from ferromagnetic materials to paramagnetic material is called the Curie temperature. Okay, example of the ferromagnetic material include the iron, nickel, cobalt. When we place these material uh, in the external magnetic field, it becomes strongly magnetized in the direction of external magnetic field. So therefore ferromagnetic materials are strongly attracted towards the magnet. Okay, so this was all explanation about the physics behind the magnetic nature of the material, and why some materials are attract by the external magnetic field, why some material are repelled by the external magnetic field. Okay, so why some material are strongly attract, some are weakly attract or repel. Okay, so we discussed that here in more detail, and we also discussed about some material do not response to external magnetic field because their magnetic domains, okay, are their magnetic their molecular magnets will do not support the external magnetic field, and the origination of the magnetic field of the molecular magnet is come from the spinning of the electron. Okay, and also it come from the orbital motion of the electron, because electron is a charged particle, and if the charge particle is in motion, it produces the magnetic field, and due to which it produces the magnetic material. Okay, the molecular magnet. Okay, and in magnetic material, that all molecular magnet will support each other. In non-magnetic material, that all molecular magnet do not support each other. So this was the detailed explanation about that, and that's it, guys. Thanks for watching.